Hi guys, welcome back to the old mill shed. I'm Jason, and today we got a little bit different video for you. We are going to be going over how to build yourself an outdoor wood stove. Now these are often called outdoor wood boilers, which is a bit of a misnomer because they do not build pressure. This entire system, at least as far as the stove goes, operates at atmospheric pressure. Now, you do get a little bit of pressure, especially like mine where I have a radiant floor system. So when your pump pulls the hot water out and it's pushing it through your radiant floor system, which is about 2,000 feet, a half inch PEX tubing, I do build between a half and 3/4 psi of a pound of pressure, which is still relatively low. But if you have anything like this under pressure, you have to go through certifications, get a boiler certificate, all that kind of thing. So we don't build these or design these to be in a pressurized uh, configuration. So basically, what this thing is, it's a water jacket surrounding a firebox. So let's go ahead and pull the sides off of this. And you can see what the inside basically looks like. Ignore these circles right here in this line. When I was drawing the grates and the grate support, I forgot that I needed to shorten everything up an inch in the drawing so it wouldn't show through. But this here, right here, is your firebox. The wood goes inside of it on top of your grates. You have an ash door. You have the main door for putting your fuel in. You have an air pipe. And then you have this little vent tube here that we will explain, but that's for later. And then you have your flue. And what I used was a piece of 6-inch Schedule 40 pipe to build that with. So on the back side here, you'll see different connections. This is a drain. This is your water return from your heat exchanger or your radiant floor. This is where your pump to your heat exchanger or radiant floor hooks in. This is your water fill tube. This is where your aquastat will sit. And these are for the connections for your domestic water heater. So you can actually bypass the water heater in your house. I couldn't draw it correctly, so I left it out, but you want to put 50 feet of 5/8 copper tubing when you're constructing this. You want to lay that down on top of your firebox, kind of open the coil up a little bit, and then they will attach, each end will attach here. Your cold water will flow in one way, go through your tubing, and come out as hot water, and then it will plumb into your hot water manifold, or you can tee it into your hot water heater. However you want to do it, we'll go over how I did it in my house. But the big thing to understand is this water system here for your hot water that will come out of your faucets is separate from this hot water system. We refer to this, the part that is encapsulating the firebox and is being circulated through your heat exchanger or your radiant floor, as dirty water. The hot water here that it will eventually come out of your shower head, your faucets, into your dishwasher, whatever you have turned on, is referred to as domestic water or domestic hot water. So what we'll do here is we will turn off everything except for the piece that we're working on. Then we will put everything back together as we go. So let's turn off the grate supports. I got the top, blower housing, Firebox top. Okay. So what we have here is the base. I tried color coding this and I actually messed this up. Let's change this real quick. If it is this kind of brown color, it is a 1/4 inch mild steel plate. And this base here is what everything is built off of. Now this particular one is 2 foot 6 inches by 4 feet. And you will see this in the cut chart when we get to the end. I have all the components laid out. And it comes out to be 2 4x8 sheets of 1/8 inch steel, a 4x8 sheet of 1/4 inch steel, and a 4x12 sheet of 1/4 inch steel. If you can't get the 4x12 sheet, you'll have to buy 2 4x8 sheets. It does generate a bit of waste. However, in my case, I was able to use the steel for something else. So this is the foundation, 2 foot 6 inches by 4 feet. And after you get that cut out, and you can actually get this clipped out on a press brake from the steel manufacturer. I think they would do 1 cut free per sheet. And if my memory serves, it was $15 a cut after that, but it was well worth it. So the next thing you want to do when you're assembling this thing is you want to tack in the firebox, the back of the firebox. And that is this part here. Now you want to install the air pipe before you do that. And this one is might as well, I actually drew this a little high. If you go 4 inches off the bottom, you're fine. And this is 3-inch pipe. You could use 4-inch pipe if you want to. It really doesn't matter. Your blower moves 50 cubic feet per minute. 3-inch pipe is going to handle that. 4-inch pipe is going to handle that. I wouldn't go much bigger, and I wouldn't go any smaller. So this is centered left to right. And if you, like I said, you just put it 4 inches, 4.5 inches from the bottom of the plate to the bottom of the pipe, you're going to be fine. That's going to work perfectly. Now, what you want to do, you want to get that square. You just want to tack it in. Just put a little tack here, a little tack there. You really don't want to weld anything in until you have everything kind of tacked in. And as a quick measurement, rough measurement, you're looking at about 3 foot 5 3/4 inches from the front of the plate to the front of this. A lot of that's going to be what you cut your sides to. You can move the front and the back of the firebox a little bit, this way or this way. It doesn't really matter. As long as you've got good welds and water is able to fully encase the firebox, you're fine. Don't overthink this. And then the next thing you want to do, let's spin this around here, is you want to build and tack in the firebox front. Now this is a little bit more complicated. These parts here for the ash door and for the main door, the fuel door, is made from drops off of the cut list, and you'll see that later. Again, the length of these pieces here isn't all that important. As long as it extends through the water jacket and out of the front. It can clear the front by 1.5 inches. It can clear the front by 4 inches. It doesn't matter. I think mine are 4 3/4 inches, 4 5/8 inches, and they're fine. They could be a little thinner and they would still be fine. And your opening is, about 14 inches on the inside. Again, that's not too awful important. Just make it to where it works for you. Now, after you get these tacked in, you want to put your firebox sides on. Now, once you get all of this tacked together, all of these seams on your firebox need to be double welded inside and out. This absolutely has to be waterproof. You cannot have any leaks on any of these seams. So you've got to lay it on its side. I used MIG. I used a flux core wire and 25% carbon dioxide, 75% argon gas. So I was double shielded when I welded all of these. And I would come up, I would put a bead here, use an air little needle scaler. Then I would lay 2 more beads on the side of it. And then I would go across with 3 beads across the top. I did that inside corners, and then on the outside corners I would come back with another heavy bead on the outside here, and then I would lay a bead on each side of that, and then a third one down the middle of it. And I have not had any leaks. You also want to double weld around your pipe here and inside. Same thing on the front. You want to have a heavy weld. Let's move this around so you can see it a little faster, a little better. You want to have a good heavy weld here, as well as on all of the seams out here. After you have gotten all of this put together, I usually go to the back and I will build this. Now, this dimension here is critical because that has to match up to your blower pipe. These, not so much. You do want these to be slightly above the top of the firebox because that's where your copper tubing is going to lay, and you don't want to be trying to put fittings in here behind there. Give yourself some room to work. So you do want those to be above the firebox top. Your aquastat, you want to be somewhere behind the firebox, but it could be down here, it could be up here. I usually drop mine down 4 to 6 inches from the top. It seems to work very well for the layout of the back of the stove when I'm wiring everything in. Your pump connections for the dirty water going to your heat exchanger or your gradient floor system. You want your intake to be up high because your hot water will rise. And then you want your cool water, which is usually only 5 to 10 degrees cooler than the hot water. You want that to come back in at the bottom, so as it heats up, then it will rise to the top. Another thing to consider is your pump is going to be sitting out here. So if you have your pump sitting here and you have your damper sitting here, your damper actuator sitting here, we'll go out and take a picture of the back of an actual stove, or I might actually just see if I can copy it in here in this video. You'll see how everything kind of lays out. Then your aquastat and all your wiring's over here. So be mindful, you really don't want to put any kind of connection here. Leave yourself an open spot to put all of your pumps and the electronics and everything that is required to make this run. You put, again, with your water fill, you can put it here, you can put it at the bottom. I had to put mine up a little bit towards the top because of the way that my pipes run. This is just a drain. You can easily just drill and tap a 1/4 hole. It will drain. Mine's a little bigger, just because that's what I had laying around. And then once you get your back on and weld it all in, go ahead and build yourself a blower housing. And this doesn't really correctly display the angle that mine is in. Actually, my blower housing kind of comes up. This is probably rotated this way a little bit more to where this hole sits about right here. But it really doesn't matter. You can lay it down flat. You can have it going straight up and down. Whatever works for your situation. All this is your little blower is going to hook onto here. It's going to transfer the air down into your blower pipe and then into underneath your grates. That is all that does. Again, don't overthink it. Move this back here. And then this, you can try to weld it on the inside. I'm going to tell you it's a tight fit, but you definitely want a good heavy weld back here on the back. If you can weld the inside of it, great, but just be aware that space is getting tight at this point. And most welds can be repaired from the outside of the stove here. If water leaks out of the stove, you still don't want it, but it's not as bad as water leaking into the firebox. So moving on, now that the back has been installed, let me delete the guides here. We are going to move on to the front. Now, you can pretty much go ahead and weld that on, and you may want to even tack on a little brace from here to here, just a little light tack there to there, just to kind of hold this. Or you could even weld in a solid piece if you wanted to. There's literally nobody policing this. So next we want to go to the front of the firebox. And like your hinges and all, you don't have to do at this point. I will tell you, the bung for the thermostat on the front of the stove is easier to go ahead and weld that in before you put this on. And this pipe here is just to protect the little thermostat, and we'll take a picture of that out at the stove as well. That pipe just keeps you from breaking the thermostat when you're loading firewood. I broke 2 or 3 on my dad's stove, which was the first one we built, and then when we built mine, we just had to put a little piece of pipe around it, and I haven't broke any in 6 years. And here the big thing is you want to just make sure the cutouts on your front sheet match where your pass-throughs are here for your doors. And what you cut out of here does not actually form the outer part of the door, but what it does do is form the part that will help seal in here. So when you build the outer part of the door, that door is actually going to be double thick. It'll be a 1/4 inch thick, actually a little bit over because you have a little bit of a gap there, instead of just an 1/8 of an inch thick. And again, you just want to tack weld it in first until you get your sides on, but this one you're not going to be able to weld around the inside, so you want to make sure you have a good heavy bead where the pass-throughs come through the front plate. And it's easier to do that if you don't have your hinges or your what holds your door handle in already. If that's all clear, you can put a good heavy bead all the way around, several good heavy beads if you want to. But like I said, just tack it first until you get your sides on, and then you go back through and you weld everything really heavily. So after you get all this done, you can actually fire it, build an open fire in here and relax your welds. We did that on the first few that we built, but we found out afterwards it really wasn't necessary, that firing it after the whole thing was complete was sufficient. So after you've got all this together, you want to go to your sides, and they are just your just blanks, 4x4 I believe they are, and we'll have the dimensions. And once you get it to this point, you want to heavily weld all your seams, and then fill it up with water. Put your plugs in back here, fill it up with water, and then you want to check for leaks. It's a lot easier to find a leak now than it is later on. And all of this gray material here, these gray panels, that is 1/8 inch steel. All of your brown rust colored panels, that is 1/4 inch steel. Now that being said, if you have only 1/8 inch steel left for your pass-throughs and not 1/4, for that part it's fine. Just where the fire is going to be, where all the heat's going to be, you just want to give yourself a little extra metal. And make sure you leave yourself room here in the front. I left about 1.5 inches. I wouldn't go much less than that. I think when we've built some subsequent ones, it was actually a bit closer to 2. But the water around the front here keeps this from burning out. I'll show you some pictures on the prototype we built. We didn't think about that in the front. We was thinking, we want to get plenty of heat capture back here and across the top. We didn't think about you need water at the front of the stove to keep it from burning out. So after you get to this point and you've water tested the sides and everything, then you want to go ahead and put on the Firebox top. Now, this pipe right here really isn't in the right place. It actually just goes on the top of the water jacket. For some reason when I drew it, it extended it down to the Firebox top. That is incorrect. I'll show you the correct placement for that here in a moment. So you just ignore that. And here is your flue. It is basically in the center of your Firebox. You do want to double weld that on the outside. and on the inside before you install it. And then the easiest way to set that in, if you have like a tractor loader, or if you're using a chain fall or something, just run a chain down through here and put a block of wood across it and run your chain as a loop around it, and then use that to sit it in. It is very, very easy to catch your fingers when you're trying to install that. So after you get that on, this is when you want to take your 50 feet of copper tubing. You want to open the roll up a little bit and work it down around your flue or your smokestack, whatever you want to call it. And then you want to attach it to your domestic water ports here. And again, it doesn't matter if your cold water comes in here and hot water comes out here, or cold water comes in here and hot water comes out here. It doesn't matter. The pressure from your system is going to dictate flow. And as long as you have the tubing in here to keep the domestic water separated from the dirty water, you're good. So after you get that done, then you want to install the top. And this right here is where that tube that I showed you is supposed to sit. It's supposed to come up out of here. That is your vent for the water jacket. It prevents your water jacket from building pressure. I actually put a T on mine, and I have a hose coming out of the side and running down, so when I'm filling it, the excess water runs out of the side and goes down to a drain pipe at the bottom, at the base, and runs out down the hill, and then it allows the steam or the hot air to escape out of the top. And as long as this just clears your metal roofing, that's all the length it's got to be. Mine's actually just the nipple that's welded on the top, and have the T, and then it's just pecs straight up from that. And I think I left it like 2 feet long. Once I put my metal roof on, then I just took my clippers and clipped it off a little shorter so it didn't look sloppy. And then again, you want to put a heavy bead all around your top here. And then all that's left is your grate supports. Mine, I actually just cut a tongue off of an old trailer. I think it was a mobile home trailer. And then I bought a full section, I think it was 21 feet of 2-inch schedule 40 pipe. And there are your grates. You can weld little nuts on your grate support to hold the pipes in place. Inside of the Firebox, I think, is right at 2 feet. I usually cut the grates about 1 inch short, so they're easy to get in there. And right now, I think a full piece of pipe is running about $115 plus tax. And they will last about 5 years. And the big thing is to clean your ashes out every day or two. You do not want them to build up. The ashes will, one, restrict your airflow coming in under the grates, and you'll only burn what's back in the back, where if you keep your ashes pulled out, the whole fuel charge will burn more evenly. And also it holds heat into the grates, causing them to rust prematurely. And in a nutshell, that's how you assemble this. Now we'll go outside, we'll take some videos of mine, but you can see how I did my doors. And then we'll take the back off of it, and we'll take a look at how the back is put together as well as the skeleton, the insulation, and the tin exterior, just to make it all look nice. Okay, so here we are out here at the stove, and the first is the little thermostat here. Here's the pipe. We use a Winters TSW style thermostat. I mean, others will work. Here's our hinge detail. Just a piece of, I guess that's 1/8 inch steel. And we found out if we make the little L on our brackets for a hinge, it swings the door away from the pass-through a little more effectively. The door is very simply made. Piece of 1/4 inch steel, piece of angle iron, a wasp there, don't see a nest, but that is how the little latch holds it shut. Just put this at an angle. The harder you push down, the tighter it closes the door. Now, looking in the door, the way this works is you have your pass-through and a piece of 3/8 to 1/2 inch square stock, and then you have your 1/8 inch door here. Then the plate that was cut out is this piece right here. This isn't one piece, it's actually 2 different pieces of steel, and a piece of square stock here. And what that does is that fits over the pass-through, and so it sits right there underneath the door, and creosote will build up around this and create a really good airtight seal. And then the ash door is the same way. As you see, I need to clean it out. We've been burning trash in here. Now, over on the side of the stove, when I was talking about the pipe that come out of the top, there's a T under here, and with the side of it comes out of this pipe, runs down into my drain pipe, just goes down the hill when I overfill it. But here's my vent tube, and it's just a piece of 3/4 PEX, and I just got it siliconed in around the roof of the stove here. And then on the back, this is my water fill, and that's how I fill my stove up. Now, I have had it drained down for a while, so it'll take a while for this to run out. So that's just how I just top the stove off every time I come out here to put wood in it. Now, I do add the anti-rust, anti-scaling solution in, and I just put a funnel, I just pour it straight down here, and it goes straight on down into the water jacket, and it works. And I put about a gallon in a year, and I haven't had any issues with it so far. So here we are at the back of the stove. I know it doesn't look as neat and professional as some of the bought models were, but we'll start on how everything works. So this right here is your domestic water in. As you can see, it comes up out of the base, it comes over. This is, let me zoom in here. So this is where I cut off the water supply to the stove. That just gives me a chance to work on it out here, and I don't have to crawl up underneath the house to turn the water out here. And put a glove on here, so I don't want to touch this mess with my bare hand. I've already killed a black widow, just taking the back door off. And this is the valve that I use to fill the outdoor stove with. So my water inlet pipe is here to the water jacket, and to fill it I just pull this and it adds water to the water jacket. And you can hear it gurgling over the overflow. And then this leads into my domestic water in. Over here is my domestic water out. And then it heads down, heading back to the house. This is the circulation pump for the radiant floor heating. And it is a Taco FBA 001 BF4J. Now this has the bronze impeller in it. It does not have the plastic impeller in it. And that you get a lot better life out of it by using the bronze. Now one thing I did do, let me flip this around here. One thing I did do is right here, I have quick disconnects if I ever have to replace the whole unit. However, the impeller is the only part that really goes bad. So you can take these 4 bolts off, pull this housing off, stick a new impeller and motor assembly in, put it back on, and you're good to go. I do have quick disconnect wiring, so when I'm out here working on it, I can just disconnect it and we're good to go. And I also can turn it off in the house before I come out here. It's just a little double safety. So this is the Aquastat. Let me get my notes out here. It is a Honeywell L4006A2015. And this just hooks back into the bung, welded to the back of the jacket there, and this comes down, and what this does is tell this solenoid here when to actuate, pick up the damper, and it also turns this blower on. Let's get in here. This little blower on. Now this comes as one assembly. You have to fabricate this little damper here yourself, and there's no real correct way to do it. I just took a cheap hinge, brazed it to a piece of metal, and then just drilled holes, put them in there, and when this thing kicks on, I don't have it turned on right now, it picks up this, and it only picks it up about that far, and that's enough. And it just blows air in, and then when you don't need air, it drops down. There's a little seal there, and a seal underneath where the blower goes into the housing, and it chokes the air off to the fire, so it just sits there and smolders, so you're not wasting fuel. Just back out here. So you got the pump. The dirty water comes out of the water jacket up here, flows down to the red pipe going to the house. I use a 1-inch PEX because I'm using radiant floor heating. I needed the flow. It returns from the house in this blue pipe and goes back in at the bottom right there. One thing I did add for this Aquastat is I have a switch over here on the side of the stove, so when I'm out here, say it's calling for heat, saying the water jacket is below 180 degrees. Well, I have mine set at 170. So say it's below 170 degrees and it is calling for air to boost the heat of the water jacket up, and I'm out here trying to throw wood in it. So right here, when I'm trying to put wood in it, I just come right here and I flip that off. And even if the water jacket needs heat, if it's calling for the blower motor to be on, it'll shut it down so it's not blowing smoke back in my face while I'm trying to load it up. Then when I'm done, I just flip that back on, and the stove is back in normal operation. So going on through the parts that you're going to need, we've already gone over the aquastat and the pump. Your blower is a Dayton 1TDN7. Your solenoid is made by Outdoor Boiler, and it's number 4184. Now, if you put in number 4184 Outdoor Wood Boiler solenoid, you're going to see them from about 8-9 different manufacturers, and they all have that same part number, and they're all the same solenoid. It's just different manufacturers have to put their name on it, so you think that you have to order it from them. Also, your spring assist damper linkage, that is this little piece right here. That is made by Central Boiler, and that's the only company I've seen that has that, and that's number 2500053. And then the thermostat around front, I use Winters TSW, but I haven't been able to find any on sale at a good price lately. But Greenwood model B2599151-2W is an almost exact replacement for the thermostat around front. Now, you don't have to have that, but it is nice to have when you're outside and you come up, say you've been away all day long, and you're just curious where your water jacket is, where your temperature is. It's good to have. It can also tell you if you have an air leak. So if your thermostat is set at 170 and you walk over there and it's at 210, you're leaking air into your firebox somewhere. It could be one of the seals on the blower has deteriorated to the point that it needs to be fixed. I had to replace one last year actually, and it was my fault. I tore it, didn't realize it. Or you might not have got your ash door shut all the way, or you may have had a piece of trash or something, like a piece of bark, caught in the main door where you was throwing fuel in, and it could have held that gap open just a little bit and it'd be sucking air up in there. So the little thermostat, while not necessary, it's a nice little extra to have. So now that you've been out here to see how this thing goes together and kind of what it looks like, we'll go back in and I'll put the cut list up for you. So here is the cut list for your metal, and all I did was I deconstructed the stove and I just laid the parts together on how they came out of each sheet, mainly just so you can kind of get a visual of what it came from a little easier. Now, obviously, when you buy your metal, you're not going to have all of these holes cut in it. So when you buy this sheet, this cut will probably be free, and you'll have to pay for 2 cuts here and here. That's the top, front, back, and then a 6-inch drop that you can use for something else. On your second sheet, 4x8, you should be able to just get 1 free cut at 4 feet. Or if it comes out to being 4 foot and a quarter, just get them to cut this in half to get your 2 sides. And these 2 are 1/8 inch, just mild steel. On your 1/4 inch sheet, 4x8 sheet, you're going to pay for, well, you'll get this cut for free, and then you can get them to cut here and here to get your 2 4-inch pieces that can be used to build your pass-throughs. And then they can cut here and here. So you're going to pay for 1, 2, 3, 4 cuts. So you're looking at $60 in cuts on this sheet. If you don't want to pay for all of the cuts, you can just get them to cut here, here, in here, and then take your plasma arc or your metal cutting saw or whatever and cut there if you so desire. And then on your 4x12 sheet, you have your Firebox sides. You have your Firebox top. Obviously, the flue or the smokestack will not be included on this sheet. And then you're going to have a 12-foot long by 8-inch drop, and then a 3 foot 3.5 inches by whatever this is drop here. Now, I had another project that all of this worked out on. You can use this for parts of the stove. You can use this for another project. If you can't get 4x12 sheets, then you may have to buy a 4x8 sheet and have this cut off of it, and then have them cut that, and then another 4x8 sheet to get the top out of, and then you're going to have even more wasted metal at the end. So that's what you have to buy, and then just some 6-inch Schedule 40 pipe. Lots of times you can go to a metal shop and they might have a scrap piece 5 or 6 feet long. That'd be fine. I would encourage you not to buy a whole 21-foot section. Alright, so this video's gotten about it's actually longer than I thought it would be, and it's actually getting longer than I want it to be. So we're going to stop it right here. There's more to cover on this that we'll cover in the maintenance video as far as the skeleton, putting the tin on. We'll get into more of the wiring, the schematic of the wiring, how it interacts with the house, how to switch the house over to this, back over to the hot water heater, things like that. So look for all of that on the next video. So as always, thanks for watching. Don't forget to like, subscribe, and hit that notification bell. We'll see you next time under the shed.